Okay, 5.6 exponential and log functions. This is a formula because your calculator only works in base 10. So if this is a different base number, you can use this formula. So for example, in part 1 already, the log of base 5 of 121, again your calculator works in base 10, but if you change it to the log of 121 over the log of 5, then you can just use your calculator. And that's going to give you, let me just grab my calculator, the log of 121 divided by the log of 5. That's going to give you 2.97979 and so on. So again, if you see the log of base 7 of 2, this is the log of 2 over the log of 7. It's called the change in base formula. Okay, the next one. How do you solve for x? So, at the beginning of this chapter, you had like 3 to the x equals 9. And you could make these look the same. 3 to the x equals 3 to the second. So x equals 2. The reason why they came up with logs is because you'll never get these to look the same. The 6 to the 2x equals 5. So what you're going to do is log both sides of your problem. All I did was log both sides of your problem. And then all you're going to do is take that little 2x and put it out in front. So what I would do first is divide both sides. Take the log of 5 and divide it by the log of 6 on your calculator. Okay, but then you're still going to have a 2x equals some decimal, like 0.898, so on. But then you still got to divide by 2. You're going to get 0.449. Go up to 3 decimals. Okay, the next one, again, you'll never get 7 to 4 look the same, so you have to log both sides of your problem. Take that 2x minus 1, put it out in front. You need to get this alone, so you need to take the log and divide it by the log of 7. So take the log of 4 and divide it by the log of 7. And you're going to get 0.71241437442. Then you're going to add 1 to both sides, so just add 1 onto your calculator, and then divide by 2 into your calculator. So x is going to equal 0.856. Okay, a couple more, same thing. You see that there's a logs on both sides of your problem, so what I would do is put the logs together on the same side. So I brought the logs together on the same side. If I want to write it as 1 log, and there's an addition sign, do you remember what the rule says to do with those two? We want to multiply those together, so that makes x squared plus 3x equals 1. So we had 2 logs. I brought them over together on one side, and I wrote it as just 1 log by multiplying them. There's a little imaginary 10 down there, so I'm just going to go the loop-de-loop method that we learned at the beginning of this chapter. 10 to the first equals x squared plus 3x. You got a quadratic, so you got to bring everything over to one side. Here comes that factoring skill again. You definitely need to know how to factor to survive in college algebra. X plus 5, x minus 2. So x equals a negative 5 and x equals 2. You should check your logs. You can't have a negative a log. So if you plugged x in there, you get a negative log there. So the only one you can keep is x equals 2. I changed the problem, so if they look a little different, it's because I changed the problem. Again, you can never make these look the same. I need to log both sides of the problem. So what I would do is maybe I would take the x minus 5 and divide it by the x minus 2, and I would take the log of 3 and divide it by the log of 2, and then I would figure out what the log of 3 is divided by the log of 2, and you would get x minus 5 over x minus 2 equals 1.58496250. If you cross multiply, which you've never probably did, a weird decimal like this, but you're going to get x minus 5 on this side, and you're going to get 1.58496 x's minus, times that by 2, you're going to get 3.169925. You need to get the x's together on the same side. You need to get the numbers together on the same side. So I am going to add 3.16 to both sides. And I'm going to get if I add 3.16 over to this side, I'm going to get x minus 1.830075 equals 1.58496 x's. I'm going to get the x's together on one side, so I'm going to get a negative 1.830075. If I subtract 1, I'm going to get 0.58496 x's. To get x alone, I have to divide both sides by 0.58496. My final answer is a negative 3.129. So this takes a lot of writing little decimals down. Same thing with this one. Log both sides. I'm just going to go a little bit faster. You're going to get really weird decimals. Put the 5x plus 3 out in front. Put the 2x plus 1 out in front. Bring the log of 5 divided by the log of 7. Bring the log of 7 over here, and bring the 2x plus 1 divided by the 5x plus 3 there. Figure out what this is as a decimal. Log of 5 divided by the log of 7. You are going to get 0.8270874 equals 2x plus 1 over 5x plus 3. Put this over 1 so you can cross multiply. You're going to get 2x plus 1 equals, take that number and multiply it by 5, so it's 4.1354 x's plus 0.8270874, multiply it by 3. You get 2.481262. And this is difficult because these numbers are weird decimals. I'm going to bring the 2x over to join this side. So if you have 4.1354 x's and you take away 2 of them, aren't you going to have 2.1354 x's? And if you have 1 minus 2.481262, aren't you going to have a negative 1.48126? And then to get x alone, you divide both sides by 2.134. You are going to get a negative 0.694 for your x value. This is hard for a lot of people because of the weird decimals. You can do the same thing with e. I can divide both sides by 3, and 6.2 divided by 3 is 2.06, repeating. E to the 0.064t equals e to the t plus 1. I need to take and natural log both sides of my problem. T plus 1 natural log of t then, and remember the natural log of e is 1 from a different chapter, and I can take 0.064t natural log of 2.06. Whoops, I guess separate this up first. This is the natural log of 2.06 plus the natural log of e 2.064t. So I need to figure out what this is. I can take this and put it out in front of that, but remember this cancels out. Again, you have a t and you have a t, so those two have to get brought together. This number and this number needs to get brought together. So 1 minus 0.064 is going to end up being 0.936 t's, and then you're going to bring this and this over, so the natural log of 2.06 minus 1 ends up being a negative 0.277, and then to get t alone, you have to divide both sides by 0.936, which ends up being a negative 0.296. So the difficult part of this assignment is because of all these weird decimals. And the last problem for this section is how long to triple your money at a rate of 4% semi-annually. A equals P, 1 plus R divided by N to the NT. If you want to triple your money, maybe you want this to be a 1 and you want to finish with a 3, that doesn't matter what numbers you use. 1 plus the rate is 0.04, semi-annually is twice. And if this is 2, then up there is also 2. So you're going to get 3 equals, this ends up being 1.02 raised to the 2t power. You need to log both sides of your problem. And that's why the 2t comes up here. So to get t alone, you need to divide both sides by this. So I'm going to take the log of 3, and I'm going to divide it by the log of 1.02 divided by 2. It's going to take about 27.739 years to triple your money.